Example 3, we're given GH is congruent to KL, GFJ is congruent to KJL, and FGH is congruent to JKL. And we prove FH and JL are congruent. So, notice the triangles are not marked congruent in any way, shape, or form, but we're given stuff. So, just want to start getting a feel for how to do this ourselves. So, sometimes they don't even give you pictures. Sometimes, like the picture's not even there. They're going to give you some stuff, so you need to start drawing a picture to represent what's going on. I did draw the picture for you, but let's mark things that are congruent based on what we see here. So GH and KL are both sides, so side GH and side KL. And we mark sides congruent with a tick mark like so. And then it says angle GFJ. When you see an angle named with 3 letters, like so, the letter in the middle is the angle we care about. So angle GFJ is angle F in this one, angle KJL is angle J in this one. Those are congruent. And then finally FGH and JKL, again, the one in the middle represents the angle we're dealing with. So FGH is this angle up top, JKL is this angle up top. So what we have here is 2 triangles with certain pieces congruent. We have all these congruence postulates about triangles. We have side angle, side, 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 side angle, side angle, 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 side. Those are the 4 properties we know to prove congruence of triangles. Looking at what's given to me, are those 2 triangles already congruent?
Yes.
By what theorem?
Angle, angle, side.
Angle, angle, side. So we're trying to prove FH and JL are congruent. So our goal, this is our goal, is we want FH, which is this side, congruent to JL, which is this side. All right. Now, a couple things that are happening here. First off, obviously angle, angle, side congruence, we've already established that. Once you prove the triangle's congruent, we have the corresponding parts of congruent triangles congruent. So we just have to verify that FH and JL are corresponding parts. So it's a pretty quick and simple proof here. So I make my statement of reasons column. For my first statement, I'm just going to write all the given information and state given. So side GH is congruent to side KL, and angle GFJ is congruent to angle KJL, and angle EF or FGH is congruent to angle JKL. Now, second step, with the given information we get angle, angle, side congruent, so I immediately notice they're congruent by angle, angle, side, and that's the reason you want to give AAS. Just you don't have to write down if 2 angles and a non-included side of one triangle are congruent to 2 angles and a non-included side of a second triangle, then the triangle. You don't need to write the whole theorem down, you just need AAS. That gives me exactly what it is. Remember from last week, the name of the triangles matters in order. So however I name the first triangle, I like alphabetical order. So if I go triangle FGH, when I name the second triangle, I need to name it in order of congruence of pieces. So angle F in the left triangle is congruent to angle J, so F first, J first. Angle G in the left triangle is congruent to angle K in the right, so G second, K second. H is left over, L is left over, H last, L last. So make sure that when you name your congruent statement that you name it in the right order. All right? And keep in mind that if we look at this, as far as the sides are concerned, correspondence of sides, if we have the names drawn up properly, FH first and last, JL first and last, that demonstrates congruence or correspondence of pieces. By the picture over here, angle G and angle K, equal angles, are opposite the same side, which means that FH and JL are also the corresponding sides. Take your pick how you want to establish that, but they're opposite and equal angles, so they correspond, or their name happens in the same position of the triangle names. So, Step 3 is the state that what I'm trying to prove, which is that side FH is congruent to side JL. And that's by corresponding parts of congruent triangles are congruent, better known as CPCTC. Every proof starts with given, logically going through theorems and postulates to make conclusions till you get to the conclusion you want, which is what we're trying to prove. Once you've proven what you want to prove, you're done with the proof. All right. A couple things about notation here that are very important. There is a difference between equals and congruent. So notice this says congruent, so I wrote congruent, 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 and so on. All right. Also, sides are, I should say, segments are congruent, segment lengths are not. So if you write GH without the bar, that's the length of GH. That can't be congruent to anything. So it has to be segment GH is congruent to segment KL. Make sure the segments are showing up over these when you want to write congruent. In your homework, some of you aren't doing that. So be careful that you're writing proper notation in your stuff.